Alright folks, today we will be doing thermodynamic, one of the questions from Daniel's examples. Let's dive right in. We have initial properties. V1 equals to 0.5 meter cube. Pressure is 4 bar. And temperature temperature is 27, or if we just do a quick calculation, 300 Kelvin. I am going to use 273 as my baseline instead of 273.15. Alright, so the device have a heater that is 120 volt, 2 ampere, and for 5 minutes. Let's go ahead and just solve it first. So work done by the heater, I'm just going to call it heat, I do not just heater, equals to V times I times delta T. So we know it's 120 times 2 times 5 times 60. Why times 60? Because I want to use 60 seconds. I want to use second as a baseline. So since it gave us 5 minutes, 5 times 60 gives me the time in seconds. So you will know that this comes down to 72 kilojoules. Alright, then we know that there is a heat loss. So I'm going to write Q loss equals to negative 2.8 joules, okay, kilojoules. What else? Okay, then the rest is normal. Alright, so what do they want us to find? They want us to find mass of the gas. Since the gas inside is nitrogen, so I'm just going to write mass because there's no it's not impure, it's pure nitrogen. Determine the final temperature. Final stages, I'm going to determine at stage 2, so I'm going to put T2. Determine the internal energy. Internal energy is U. Energy, the change in the internal, so they want delta U. And last but not least, work done by the gas. Alright, so we need to find 4 things. Let's go ahead and dive right in. M. How do we find M? Right off the bat, we know that PV equals to mRT. In thermodynamics, this equation is your best friend. Alright, so they want us to find M, so let's isolate the M. PV over RT gives you the mass. Alright, do we have our PV? Do we have our RT? We do. Based on the initial condition, as you can see, we have P, we have V, we have T. Do we have R though? Remember, R is just, I'm just going to write it, Cp minus Cv equals to R. So let's go ahead and sub that in. So we have 4 bar, so to the power of 5, times we have 0.5. I'm going to use all this in base unit. Alright, so the R we have is, what do we have? Is 1.04 minus 0.743 to the power of 3, okay, times Kelvin, okay, remember in Kelvin, so 300 Kelvin, sorry, not Kelvin, and we will get 2.245 kilogram. Is this the same as the answer? Yes, it is. So we have found our mass. Let's go ahead and minimize this. So that's our mass. What do we want to find next? T2. Alright, so how do we find T2? Let me think. Alright, looking at my formula sheet, I have Q minus W equals to energy change. I have Q equals to MC over delta T. I have delta U equals to MC over delta T, and delta H equals to mCp delta T. What is delta T? Just to make sure, is T2 minus T1. Oh, T2, this is what we want to find. Maybe we can use one of these equations. Let's go ahead and see. Alright, right off the bat, we know that we cannot use the second one. Why? What is C? We don't know what's C. Can we use CV or CP? Which one should we use? Let's dive right back into the question. So the question have a heater that's heating up our gas. Common sense, heating up our gas, temperatures goes up. Now, which one stay constant, which one change in terms of PV over T? You know, if it's constant. Something have to change, something have to stay constant. Can both change? Why not? But let's see. We know that it's a piston with a constant platform mass, whatever you like to call it, this little guy right here. So if my temperature keep increasing and my pressure builds up, pressure is just more force over the same area. And since the force is increasing, or rather pressure is increasing, my force should be increasing, right? So this piston now get pushed up more. It push up more means volume increases. But just now I said my pressure increased. Yes, my pressure increased only to increase the volume, which in return reduces the pressure. So technically, my pressure stays constant. So I'm just going to put it very clear, black and white, that when my temperature increase, my volume increase, my P is constant. So with that being said, since my volume increases, I cannot use CV because it is not constant volume application. However, I can use CP because it is constant pressure application. Which this brings me, now that I have change in enthalpy equals to mass times the constant pressure times, okay, I'm just going to write T1 minus T2. I have everything but this bugger and this bugger, but this is what I want to find. So that means I can find my delta H. How? Back to the first equation. So my delta H equals to Q minus W. But let's be very, very specific. Q minus W is all related to the system. What do I mean by that? Q from the system minus work done from the system. Alright? So we have identified that the Q loss is 2.8 kilojoules. Now, is it negative 2.8 or positive 2.8? It is heat loss from the system. Heat loss means I'm removing. Now, minus W system. Alright, so the heater, we know that it is 72 kilojoules. But is it minus? The heater is actually putting in work into the system. So that means the system is gaining work. Alright? And there is no work done by the system, but rather onto the system, which means this is actually plus 72. So with this being said, our delta enthalpy is actually 69.2 kilojoules. And with that, we can find our T2. So we have 69.2 kilojoules equals to, what's the mass? 2.2, wait, what is it again? 2.245 times CP. CP is just 1.04, and then times delta T2 minus T1 is just 300. Right, because we know that this is to the power of 3, 10 to the power of 3, and this is kilo, so I'm just going to omit this. So we're just going to put in this number as such. So after pressing your calculation, T2 should be, let me just go ahead and press it, divided by 2.25 divided by 1.04 plus 300. So we will get 329.6 for Kelvin. You can leave it in Kelvin, I guess, but just for answer sheet sake, because they leave it in Celsius, is 56.64 degrees Celsius. Am I right? Woo! Right on the dot. Next, what do they want us to find? Alright, so we found mass. We found this. They want to find internal energy change. So internal energy change, okay, I mean they are asking us to find precisely this. So we're just going to sub it in. So 2.25 over 0.7, is it 743? Yeah, 743 over what was it again? Oh, 29.64. You should get 2.25 times 0. You should get 49.44 kilojoules, because I didn't change this. Alright, I just straight away just key in this number and I should be correct. 49.44. Yep. So you might be asking yourself, but you literally just said that do not use internal energy change. Then why are you still using it? Well, first thing first, question asked for it, and what the question is trying to do is more of, they want you to find what is the energy change at this particular for this particular factor alone. Because I can say that the total energy change equals to U plus like a certain extra stuff, which essentially becomes your H. U plus a certain extra stuff, based on my understanding. Alright, so moving on to work done by the gas. What do I mean by work done by the gas? So we know that in this particular system, okay, we have heat being put in by the heater. Okay, so I'm just going to write it down here, maybe in purple. So we have work done by the heater, and they want us to find work done by the gas, and then we know there is heat loss from the system, and we know that there is internal energy found from the previous one. So we know that the work done from the gas equals to the total work done from the heater minus the losses, okay, minus the internal energy change. Logically, this makes sense. Now it might look like I'm just throwing all the thing inside because the answer sheet at the end of the day is correct, but no. This will give me like my total input. Then not all machines are 100% efficiency, you know what I'm saying? So this is like the losses. Then this is the work done from the system itself. So this will give you the work done by the gases. But you can say the gas is part of the system. You're not wrong, but at the end of the day, it's just what do we identify in our system. So anyway, so we know that the work done from the heater is just 72 minus heat loss, 2.8. Now notice how I said minus heat loss, but then why is it not like this? Because we're already removing the 2.8. And then minus the system, which is, what was it again? 49.44. and this is 72 minus 2.8 minus 49.44, which give me 19.76 kilojoules, and my answer should be correct. There we go. And this is how you solve this particular question.